Okay. Good morning, good afternoon, good evening, guys. We're going to have a look at annuities today. So this is a really similar model to reducing balance loans. Okay, we've seen that earlier. The definition of an annuity is it's a compound interest investment from which you take regular payments. Okay, or regular payments are withdrawn. So our model for this, to kick us off, is stick a pen. Be a bit better. Our model for this is that R is the interest rate per compounding period. Okay. D now is the regular payment that you're receiving. And R is equal to 1 plus R over 100. Okay. And the recurrence relation gives us what's left. Okay, so what's left after n payments. Alright, so we'd have V of 0 is equal to the principal, which will be the investment. It's the worst principal I've ever written. Vn plus 1 is equal to R times Vn minus D. Okay, so as you can see, we've got the rate that you're getting for interest, how much you invested in the first place, and then this is your regular repayment, so you're taking something out which will be in excess of what interest you get. Alright, so let's pop that into practice now. Go to another slide. Alrighty. So, let's just say you've got a friend Renee is travelling for 6 months. She invests $12,000 at 6% per annum, and that compounds monthly. And she will take $2,035 per month as her allowance for 6 months. Okay, so based off that, we want to A, write the relation, B, find the value of the annuity after 3 payments, C, find out is the annuity fully paid after 6 months. If not, what should the final payment be? It'll either be more or less than the $2,035 that she's originally drawn down. Okay, so let's crack on with that. Firstly, write the current relation. So we know for A, V of 0 is $12,000. Vn plus 1 is equal to R Vn minus D. So to find that, we need our little r is first off, because that's per compounding period, 6 divided by 12. So little r is equal to 0.5. That means big R is equal to 1 plus 0.5 over 100, which is obviously 1.005. And we also know that she's taking out, assuming Renee's a she. Not trying to cast any assumptions or that sort of thing. Could be in France where Renee's more of a male name sometimes. Anyway, enough of that. So our recurrence relation, if we continue with that, is Vn plus 1 equals, as my email goes off, 1.005 times whatever Vn is. Take 2,035 away. Okay? So that there is our recurrence relation. Next up, we want to find what the value of the annuity is after 3 payments. Okay, just cut that off there. So after 3 payments, that is a B, not that it looks like one. Not much better. Okay, so to find after 3 payments, into your calculator, let's type in 12,000 and execute that. This predictive writing style of this pad sometimes makes it look stupid. Then, after you've done that, hit times 1.005 minus 2,035, and then hit your XE, and you want to hit that 6 times. Okay, we may as well do it for the whole 6 months. Doing that, you'll end up with figures that come down as 10,025. Then the next time you'll get 8,040 and 13 cents. Then 6,045, 33 cents. Then keep going. So we've already got the answer now anyway, but finish off our 6 payments. 2 to 5.6, and then 0.88. Okay, so after 3 payments, so they get 1 payment, so it shows up a bit more. We get 1 payment there, first payment, second payment, and after 3 payments there is $6,045.33 left in the annuities. Okay, and then so 3 payments, 4th, 5th and 6th. Alrighty. C, is the annuity fully paid after 6 months. We'll stick on this page. So after 6 months, we can see that the annuity still has a worth of 88 cents. So what would happen then is, because we're owed 88 cents, that final payment is going to go up. Okay, so instead of 2035, part C is going to be 2035 plus 88 cents. 2035.88, so that it's fully paid down in the 6 months. Okay, we can also use the finance solver to look at our annuities. Okay, we need to remember some of the rules around this. If the bank gives you money, it's a positive. You receive money, it's a positive regardless of if you're in debt. Bank gives you money, it's a positive. You give the bank money, it's a negative. You owe someone money, it's also a negative. So for instance, in your finance solver, the previous value could be a negative, will be a negative, sorry. So PV will be a negative. Why is it a negative? Because you gave the bank money to start with. Okay, payments. Will be positive because you receive, you get, I can't spell you and get, they're two separate words. You get payment. Okay, future value will either be positive or 0. Okay, the bank will pay you more if it's positive. The annuity is fully paid if the future value is 0. Okay, so let's look at this as a problem. Go to a clean page. Skip back to it if you need it. Alrighty. You got a mate. His name's Joel. He invests $200,000. Okay, paying 5%, compounding monthly. All right. Let's move this over a bit. A, if paid monthly for 10 years, what will be received each month? B, if he receives $3,000 per month, how long will the annuity last? Nearest month. C, what rate to 1 decimal place would allow Joel to get $2,500 each month for 10 years. Okay, that's what we'll work on. Alright, part A. I don't want that to be red. I don't know why it does that to me. Okay. Anyway, we'll leave it for now. So A, paid monthly for 10 years. So we want to punch in our finance calculator. N, the number of payments, he's paid monthly. So that's 12 times 10 years, or you could put in 120 for those of you who know your 10 times table. The I, percent interest, is going to be 5% as stated in the problem. The present value of the annuity is $200,000. So you might think of this as something like superannuation. You realise that you need a fair bit. Remembering that that's $200,000. Oh, that's big, big, big. Is a negative $200,000. You've given that to the bank. The final value, okay, he doesn't want any of it at the end, assuming Joel's going to die, is 0. Payments per year is 12. Compounding periods per year is also 12. Okay, and once you've got that, solve for PMT. And you get an answer of $2,121.3103. So let's make it finance. So we go to two decimal places, sorry. So he can get that much a month for 10 years. Part B asks us to think about if he receives $3,000 a month. So he goes, right, I can't live off that. So we go part B for $3,000 a month. We want to change payments in your finance solver to 3,000. That's what he wants to be paid a month. Okay. Now, after that, solve for N. So we know how many months he can get paid for, and you'll get a value of 7,826.4 if we round it, or 78 months. So what's that? Just over between 6 and 7 years. All right. Part C, what rate to one decimal place would allow Joel to get $2,500 each month for 10 years? Okay. Part C. We want to change our payments to 2,500. How much he says he's happy medium for him to live off, but he wants to negotiate a better rate with the bank. We also have to change N back to 12 times 10, or 120 for the number of months he wants it to last for, and then solve for I percent. Alright, and we get an answer of 8.6892, or to the nearest decimal place, 8.7% is the interest rate Joel would want to get, so that he gets $2,500. Okay, so he gets that much there over 10 years. So he finds a bank or an institution that gives him that, and he's happy. Okay, so I hope that explains most of the annuities to you. So what we want to take out of it is that It works similar to a reducing balance loan, except you've invested the money in the first place. So you've got a positive balance. You've given the bank money, and then from there you're drawing out money as a sort of allowance each week until it runs out, or each month, depending on the period that you're drawing it. Okay, I'll pop this one up. Hope you enjoy it. Hope it explains stuff. Leave any comments you want. And yeah, cheers. Have a good day, guys. Bye.